Okay, so continuing from the previous video, this is the last code that we created, and we already get the image after applying closing process here. Okay, and this is the image. This is after the closing process. And next, I want to talk about contours in OpenCV. So, what are contours? So, contours in image processing are curves that connect all the continuous points along a boundary with the same intensity. In simpler terms, a contour is a line or a curve representing the boundary of an object in an image. So the use of contours, this is for object detection, useful for identifying objects within an image. Shape analysis helps in understanding the shape or structure of an object. Image segmentation separates different objects within an image. Measurement allows measurement of geometrical properties such as area, perimeter, etc. Now, how do we detect contours in OpenCV? So the first step is the image pre-processing. To detect contours accurately, the image needs pre-processing, such as convert the image to grayscale using cv2.cvt color. We already done this, and applying threshold or edge detection like cv2.threshold or cv2.canny. We also already done this. Also, we add morphological operation like closing, and then the next step we need to use the cv2.findcontours function. And this function is used to detect contours in a pre-processed image. So here, this is the function. So contours hierarchy is the output cv2.findcontours, and it has like 3 parameters that we can choose, that we can use. Okay, so the first one is image. This is binary image. This is output from thresholding or edge detection, or in our case, this is output from the closing process. Next, the second parameter is mode. This is contour retrieval mode. It has 4 types of mode. Oh yeah, also if you want to read more about contours in OpenCV, I can go here, contours in OpenCV. In this first video, I took the reference from here actually. So this page of documentation explains about contours in OpenCV, how to draw contours, and contour approximation method. So yeah, you can read more here about contours in OpenCV. And let's go back. And here we talk about cv2.find contours. You can also read more in here. Find contours. And next, there are 4 retrieval mode. So first one is retro external. This retrieves only the outermost contours, ignores nested contours like holes inside objects, and this is best for detecting isolated objects or text regions. And second is cv2.retterlist. This is retrieves all contours without establishing any hierarchy. Contours are stored as a flat list, and this is for simple tasks where hierarchy isn't needed. Third is retroscomp. This is retrieves all contours and organize them into 2-level hierarchy. So outer contour as the first level, and the second level is holes or inner contours. Best for detecting objects with holes like alphabet O and P. And the fourth is cv2.retter3. This is retrieves all contours and organize them into a full hierarchy of nested contours. And it tracks parent-child relationships among contours and best for complex shapes or structural text layouts. So if you go here in this page, you can see find contours. Use 3 parameters: image, mode, method, and output is contours hierarchy 2. Okay. Here the parameter mode for contour retrieval mode. See retrieval modes. You can see the retrieval modes here. There are about 1, 2, 3, 4, 5 retrieval mode, but yeah, we only use like 4 of this. We're not using float fill actually. Okay, let's go back, and this is the summary table if you want the summary for 4 modes. Next, the method. This is contour approximation method. Also have 4. First one is CV2 chain approx none. It stores all points along the contour boundary. This is have high memory usage because it retains maximum detail. This is best for detailed shapes or irregular contours. Second is CV2.chain approx simple. It removes redundant points along straight lines and only keeping the corner points. And it has low memory usage because it simplifies representation. And this is best for OCR tasks and detecting geometric shapes. Third one is CV2.chain approx TC89L1. It simplifies contours using the Bayesian algorithm using L1 metric. It balances memory efficiency and contour accuracy, and best for moderate shape simplification. And the fourth one is chain approx TC89K cos. This further simplifies contours using the Bayesian algorithm using K cosine metric. It focuses on retaining only critical points and best for highly simplified shapes or minimal detail tasks. And this is the summary table if you want the summary of 4 of the contour approximation method. So probably from the retrieval mode, I'm going to use retrieval external, and for contour approximation method, I'm just going to use CV2 chain approx simple. Okay. You can also read more here about the method, the contour approximation method. You can see contour approximation modes, and here's the contour approximation modes. It has 4 of this, and I'm gonna using chain approx simple in this tutorial. Okay, you can read more here. Okay, for parameters, I'm not gonna use offset. I just want to keep this video simple. We're not gonna use offset. Okay, back to the Jupyter Notebook, and the outputs of CV2.findcontours are contours. This is a list of detected contours, each represented as a NumPy array of x, y points. And hierarchy. This is information about the hierarchical relationship between contours. So for role of contours in OCR, this is for identifying text regions. Contours are used to detect sections of the image that are likely to contain text, such as paragraphs, words, or characters. This helps isolate text from the background. And the preprocessing for OCR, this is by leveraging contours, you can focus on relevant text areas while ignoring noise, non-text elements such as images, lines, or decorations. And contours can generate bounding boxes to segment text areas for OCR processing. And third one is improving OCR accuracy by separating text into individual regions, character or words. OCR models can better recognize and process the text. Okay, so this is what we are aiming. Okay. Okay, next, I want to check first which OpenCV version that I have, and I have OpenCV version 4. Why? Because apparently on CV2 findcontours on OpenCV version 2.x and 3.x, it returns 3 variable. Meanwhile, on OpenCV 4.x returns only 2. So that's why I checked the OpenCV version that I have right now. Okay, and here I am using version point.x, so it returns 2. That is contours and hierarchy. Okay, so in this function, I'm using the closing image from the previous video, and then for the retrieval mode, I'm using CV2 retrieval external, because I only want like the outermost contours when we want it to be the paragraph, so we ignore the nested contours. And on the third argument, for contour approximation method, I'm using CV2 chain approx simple, because assuming paragraph is like a rectangle, so we have straight lines and we want to keep only the corner points, not the points along straight lines. But you can also try with other retrieval modes and other contour approximation method if you want. Doesn't have to be like what I'm using right now. Next, I'm showing you that the function returns the contours as a tuple. This is class tuple, and here the length is 25 contour. It has 25 item, 25 contour, and each contour is actually a numpy array. Okay, this is numpy array for the first contour. And here, let me print the first contour, and the length is about 34. This is the second contour, and the length is 5, and the third contour, and the length is 6. Okay. Okay, I think that's it for this video. Next, I want to talk about a little about contour features, specifically about a bounding rectangle after this. Okay, thank you.